Good afternoon, everyone. Those of you who have joined either via YouTube or via the Teams app, uh, just by a show of hands, those guys on Teams and on YouTube, if you want, can you just by a show of hands uh, give by a thumbs up or just writing yes in the comment section that you can actually hear me before I continue? Okay, thank you. Thank you. Okay, today we're dealing with angular momentum and torque. Okay, thank you, Mr. Isaac or Tabazo. Isaac, thank you. Okay, today we'll be dealing with angular momentum and torque. Now this is a very, it's not a difficult concept, but it's not one you have done in high school, so it's kind of, it takes getting used to. Okay, so I'm going to highlight a question that I'm going to do, and I know some of you who have after that poll, you say that we take too long doing, say, 5 questions. The reason why we do that is because we want you to understand what we are doing. Okay, so you can actually do it by yourself. Okay, now let's do this question for instance. It says a light rigid rod of length 1 meter. So there is some rod. Let's try to draw it. Okay, so there's a rod, basically a stick. Okay, this is the stick. Okay, and this stick is joining. It is 1 meter long, so it is a length of 1 meter. The stick, it is a 1 meter long stick. Let me just move it upwards. To draw what they're telling. This is always a good starting point for any physics problem. Try to visualize either via a free body diagram, a vector diagram, what is actually happening, so you can actually see in your mind, so you can visualize what is happening. Okay, so you have this rod. It's rigid, meaning it's not bending. Okay, it joins two particles with masses m1 and m2. So there are two particles. Okay, here's one particle and this is another particle. Okay, you don't have to consider this in terms of like electron, those type of particles. This is just a mass. So this m1 and this m2. Okay, so you have two particles, m1 and m2, and they each have different masses. Okay, and I'm just going to write here m1 is equal to 4 kilos, 4 kilograms, while m2 is equal to 3 kilograms. M1 is equal to 4 kilogram, M2 is equal to 3 kilogram. And this is at the end of this 1 meter rigid rod. Okay. Now they tell us that the combination rotates in the XY plane. Okay, so if this is the, let's say this is X and this is Y, then this would be the plane would be the XY plane. Okay, so far so good. We've just drawn, or we've just used what we've been given, and they rotate, meaning it's turning around about a pivot through the center of the rod. So somewhere here in the center of this rod here, if I were to say, let's say I'm taking this cookie and I'm rotating, I don't know if you can see me. Okay, so this is the cookie I'm having. Okay, so blue pen. Okay, so it's rotating through a point. So it's rotating about a certain point at the center of this rod. So around this point here, this rigid rod is rotating around this point in the center here. Okay, So imagine a broomstick, a 1 meter long broomstick, and at the end of those broomsticks, you've attached, say, somehow by whatever method you have attached two balloons, okay, filled with water, okay, and one is 4 kilogram, the other is 3 kilogram, and now you've, say, drilled a hole through this balloon. In its center, you drill a hole right through the center, and you've inserted a nail or a piece of iron, whatever. Now you are slowly rotating this balloon. If you can, let me do the blue pen. Here in the center, you are now rotating this system with the two masses at the end and this rigid rod in the middle. You're rotating it in the XY plane. And they are asking us, determine the angular momentum of the system about the origin. The speed of each particle is 5 meters. So if you are rotating this thing, its speed, they tell you, you start rotating it, so it's going to start moving in a, say, in a circle. Okay, this is going to be a very bad circle. Let's say this is the circle, and this system is going to start rotating in that circle. It's a terrible circle, I know, and it's going to rotate with a certain velocity v. Okay, and that velocity, they told us, is equal to 5 meters per second. So v is equal to 5 meters per second. Okay, so now we've written down everything, we've drawn the situation, we've written down all the information that has been given. We can now begin to answer the question. First of all, what is angular velocity? Okay, angular velocity. How do you calculate angular velocity? Okay, so just picture this in your mind. We have this solid broomstick, rigid rod, and we've drilled a hole through it. We have attached two balloons at each end, one weighing 3 kilogram, one weighing 5 kilogram. We've put a nail through that hole and started rotating this broomstick or rigid rod, and it's moving at 5 meters per second. Okay, it has a speed now of 5 meters per second. And remember, the length of this rod is 1 meter. Okay, so if the length of the rod is 1 meter, the diameter of the circle will be 1 meter, meaning the radius is half a meter. Okay, so I continue. How do we calculate the angular velocity? Oh, let me just write in here the radius then would be, if the radius is then 0.5 meters. Okay, the radius will be 0.5 meters. This is everything we've been given. Now, angular velocity, they determine the angular momentum. We need to determine the angular momentum. Okay, so, angular velocity. Let's first calculate the angular velocity. Okay, because momentum is some velocity multiplied by its the velocity multiplied by its mass. Okay, so we are going to first calculate the angular velocity. In this case, angular velocity is equal to the linear velocity divided by the radius. Okay? Angular velocity is the linear velocity divided by the radius. Okay? So this is angular velocity, this is the linear velocity divided by the radius. So the linear velocity that they gave us is 5 meters per second. So the linear velocity divided by the radius, which is 0.5 meters, will give us the angular velocity of, an angular velocity of 5 divided by half is 10. 10. Now angular velocity has units of radians per second. Okay, so radians per second. So we have calculated the angular velocity right now. Angular velocity is equal to the linear velocity that they give you divided by the radius. In this case, they told us that the speed, or the linear speed of each particle, is 5 meters per second. Now the moment of inertia for M1. Now remember, we have two masses, M1 and M2. Okay, now in order to calculate that angular momentum, we need to calculate the moment of inertia for both of those masses. Okay, so the moment of inertia for M1, and I'm going to show you now how to go about calculating a moment of inertia. So the moment of inertia for M1, we'll denote it I1 equals, now the moment of inertia is just the mass multiplied by the radius squared. That is the inertia, the moment of inertia. Now the mass of M1 is 4 kilograms and the radius is 0.5. We square that. Mass is in kilograms, radius is in meters. This will give us an answer of 1 kilogram, and that is in meters squared. Kilogram meter squared. Another name for moment of inertia is the angular momentum. You can also call it the angular, well, not exactly, but the inertia multiplied by the angular velocity will give you angular momentum. Okay, so we have the angular velocity for both of these masses. We have the moment of inertia for M1. Let's calculate the moment of inertia for M2. The moment of inertia for M2 moment of inertia for M2. So I2, the moment of inertia for M2 is equal to the mass of 2 multiplied by the radius squared. So the mass of 2 is 3 kilograms and the radius is 0.5, and we square that. This gives us 3/4 kilogram per meter squared. So now we have the angular velocity for M1 and M2, and we have the moment of inertia for M1 and the moment of inertia for M2. Now, total angular momentum, which is what we want. Now, total angular momentum. The total angular momentum is then equal to, well, angular momentum is L. The total angular momentum is equal to the inertia of the inertia of the first mass multiplied by the angular velocity plus the inertia of the second mass multiplied by the angular velocity. That is how you will go about getting your total angular momentum in this case. So the total inertia, the inertia of the first one is 1. Remember, we calculated to be 1. and the angular velocity was 10. The inertia of the second one is 3/4, and the angular velocity is the same for both because they are attached. So this would give you your angular momentum. 10 plus 3/4 of 10, which is 7.5, I think. So the answer, the total angular momentum is thus 10 plus 7.5 is going to give you 17.5 kilogram meters second per second. 17.5 kilogram meters per second. Just to recap, in order to calculate in this system here, for this system here, this system that we draw here, we want to calculate the total angular momentum or the angular momentum for the system. Okay, so we wanted to calculate the angular momentum. In order to calculate the angular momentum, we needed the angular momentum of m1 and the angular momentum of m2. Now the angular momentum of m1 is equal to the angular velocity of m1 multiplied by the inertia of m1. And the angular momentum of m2 is equal to the inertia of m2 multiplied by the angular velocity of m2. Now, since they are attached to the rigid rod, it's not bending, the angular velocity will be the same for both of them. And angular velocity is just the linear velocity that they've given us divided by the radius. Okay? And then moment of inertia for each one of them is just the mass of the particle multiplied by the radius squared. That will give you the inertia. And then finally, angular momentum is equal to the total angular momentum is just equal to the angular momentum of the first one plus the angular momentum of the second one, where angular momentum is just the inertia multiplied by the angular velocity. Okay, that is a very nice problem. Let us continue with, if you have any questions, just ask. But I'm going to give you, say, 10 seconds if or 20 seconds while I'm getting ready here. You can type a question in the chat or just put on your mic and ask if you want. Otherwise, I'm going to continue if there are no questions. You can ask on this work, by the way. You can ask regarding this type of work I'm doing here, or you can ask on something you did in class. Okay? I will try to help you as best I can. If I cannot, then I will, of course, ask you to email me the specific problem that you are working with. I'll go work it out for myself, and then I will send you a worked out version of the problem you're struggling. Or if you really want that, and if you still don't get it, then I will arrange a Teams meeting with you if you want that. But for now, I would suggest you please ask me now while we have time. I know a lot of you don't like asking questions in this type of space, but this section of work is usually what trips the students because it's near the end of mechanics, and so far you've written your first semester test. Now you're getting tired of physics. Okay, there seems to be no questions, so I will continue. Let me just scroll upwards. And there it is, the answer 17.5 kilogram meters per second. We can check it. Check. And yep, it's correct. Question 2. I'm going to show you the picture now. This is question 2. This is the picture that goes with question 2. Okay, they say find the mass of the counterweight. Okay, so find what must this counterweight be? Find that mass needed to balance that truck. Here, needed to balance that truck. What a mass of 1.5 ton. So this truck weighs 1.5 tons or 1500 kilograms or 1500 kilograms on an incline of 45 degrees. So this is 45 degrees. So let's write it in there, 45 degrees. And assume both the pulleys are frictionless in the map. Frictionless and massless, okay? So basically we have a mass here. We have a mass, okay? M, and Ayabonga, some tiang, some Tingana. Okay, I'll just call you Ayabonga. Did you have a question? I see there it came up and then message retracted. Do you have a question? And I'm sorry I mispronounced your names. Let me try again. Somtiyingana. Somtiyingana. Okay. Ayabonga, if you have a question, just type it. It's okay. You can type it. I'll also answer it. Okay, so we need to find a mass in this case. This is the problem, by the way, that you're going to have to be asked to do. Okay. I know you guys, some of you, you've already written a test with Dr. Waswa. Those of you who are with Prof. Olivier, you're going to write this Saturday. And he did send you out earlier on. He sent you out some exam papers, and I've looked at those questions in those exams. Trust me, he's going to ask similar type of questions. So you need to be on top of your game. Okay, so we have this. We'll call it a baki because this is what it is in South Africa. It's a baki. We have a baki connected via a pulley system. There is a pulley on the baki, a huge pulley, which is then connected to a larger pulley, and which is counterweighted by a mass M. Now they're asking us find the mass that needs to balance this truck's mass in order for it to be balanced. Okay, so in order for the truck not to move, what must mass be here? Okay, what must that M be? Okay, I guess everyone gets the gist of the question. How do we go about then uh, answering this question? First of all, we draw a force diagram. Okay, a force diagram. Now, I'm not going to draw the whole force diagram. I already have one here. So the forces acting on this buggy is as follows. Okay, its weight is acting straight down, so it has a weight. This buggy is his weight. Its weight is working straight down, and its weight is equal to the mass of the buggy multiplied by g. That is the weight of this buggy, mg. The mass of the buggy multiplied by its gravitational acceleration. That is the weight of this buggy. The next force acting on this buggy is both the horizontal and the not the horizontal in this case, the horizontal and vertical if you twist it around, but in this case the parallel force of weight, the parallel component of the weight in this case is going to be equal to the mass, the weight, which is just going to be the weight times the sine, because it is going to be opposite. It's going to be opposite over adjacent, so it's going to be sine theta. So that's the parallel force, and then we also have the force that is going downwards. That's going to be, of course, this force here, and that force is the weight mg multiplied by the cos of theta. Okay, so there are three forces. Of course, this is not to scale because just wanted you to see the arrows. If this was to scale, then the weight would be the bigger arrow because the two of them would be equal to the sum of these vectors must be equal to the weight. So the forces on the bucky is the parallel force due to its weight, and then the perpendicular force due to its weight. Now there is one other force as well. Okay, this force is in this rope. Okay, it's the tension in that rope. That's the other force that is also present here. Tension in the rope. And then before we forget, this mass, of course, here has its own weight, small m g. Okay, that mass has its own weight downwards. Okay, I just drew in all the weights, of course, and I will refer back to it if needed. Okay, we've already established that this angle there is 45 degrees. Now we know, let's just start. There is two tensions here. Okay, this part of the rope is tension, and then also this part of the rope. Okay, same tension, T. In both of them there is T in this part of the rope and a tension in that part of the rope. Okay, now in order for this bucket to be balanced, okay, let me just write down something. In order for that bucket to be balanced here, okay, all the forces in the vertical direction, meaning in the perpendicular direction, must equal, and all the forces in the parallel direction must be equal. This means that mg sine theta must be equal to the tensions here, the two tensions. Okay, now if I write that out, okay, we know or should know that mg sine theta, so the parallel force of this bucky, should be equal to those two tensions, tension 1 plus tension 2. That is what is happening here. We have tension 1 and tension 2, the tension in those two in the rope, and then the parallel force. Those are all the forces acting in the parallel direction. And T plus T is just 2T. You can write it as 2T. Okay. Now if we substitute all the values in, okay, we are given that the big mass, the mass of the truck, M, is equal to 1,500. I'm not going to include units because I don't have the space. G is 9,8. And then we have the sine of 45. The sine of 45 degrees is equal to 2t. If you have a question, please just raise your hand or type it in the chat. But I suppose that most of you are with me so far. Now, if we calculate it out, sine of 45, 1 over square root 2, if I'm not correct, if I'm not correct, if I am correct, let's just make sure. Why am I pronouncing words wrong here? 1,500 is 0. 1,500 multiply. You can check on the calculator at the bottom. I'm doing the calculation myself. 9,8 multiplied by 9,8 multiplied by the sine of 45 degrees. Close the bracket. The answer is 10,394.5. Now if I divide that, let's clear all. Let's say 10,394.5 divided by 2. Because remember, this is equal to 2t. We want t. Therefore, T is equal to, divided it by 2, that's 5,197.25. So that is also, of course, it is in newtons. Okay, that force is in newtons. The tension is 5,197 newtons towards the right, okay, or upwards towards the pulley system. So we have worked out the tension here. Okay, we want this mass. Okay, so we've worked out the tension. We've worked out the tension, but here we have a mass of pulley, a big pulley. Okay? Now, in order to calculate that mass M, okay, we can calculate this mass M by using the torque equation. Okay, torque. Okay? It's the amount of force acting at an angle. Okay, so in order to calculate that mass there, okay, we have the tension in the rope. We have the tension in the rope here. T, we have it here. That T we have on that rope, that tension. And then on that rope, now we want this mass here. This mass, we want that mass. Okay? But it is acting on a pulley. Okay, now when dealing with pulleys, the easiest thing to do is to work out the torque. Now the torque is just the radius for a pulley, is just the radius multiplied by the force. Okay, the radius multiplied by the force. Nothing but the radius multiplied by the force. So let's see. The radius in this case is the big three R right here. The radius of that whole circle is 3R. Its radius is 3R. So we have 3R, the radius, and the force on it due to this weight is just the mass going down, or it's just its weight going down is m, small m times g. So we have mass, so we have the radius times the force, and then of course there's a force on that side as well, and this force is acting at a radius of small r, just 1r, the small r. Okay, it's a little bit fuzzy now, but the tension, this one, it goes around and then until it enters the big circle. Okay, so the tension goes into a pulley that has a radius of, the tension goes into a pulley that has a radius of r, and force, which we worked out right now, that force is the tension. So we have two forces. I'm going to draw what is happening here. Basically, this is what's happening on that rope. We have a small r and then big R. Okay, this is what is happening. Then we have two forces. Okay, one force is going down. This is the force of the weight of that block hanging there, and then we have the force of tension coming in, force at small r. Okay? And this one holds the bucky, of course, here. There's the bucky here. This is what's happening. Now, the force here is the tension. The force here is the tension, and the force here is the weight. This tension acts on a circle that has a radius of r. Okay, it has a radius of r. This one has a radius of r, and the bigger one has a radius of 3r, meaning 3 times this smaller one's radius. Okay, now when you work out the torque, for this one should be equal to the torque for that force. The torque for this force should be equal to the torque for that force, because this car is balanced. Okay, it's not moving at all. Okay, so we know that torque is equal to the radius of the pulley multiplied by the force acting on that pulley. Okay, now the force acting on the pulley downwards is the tension, and it acts on a radius of just r, and that's the tension. And on the other side, we have a force of the mg, the weight of the block, and it acts on the big pulley circle, which is the radius of 3r. Okay, so this is where we are now. For the torque on the, let's call it the left hand side. So for the torque on the left hand side, let me just show you again. For the torque on this side, let's just divide this thing and say the torque on the left hand side, we have the tension multiplied by the radius of the small circle, and the torque should be equal to the torque on the right hand side, which is just the mass times the gravitational acceleration, which is the weight of this block hanging there. Remember, we want that m multiplied by the radius of the big pulley. In this case, we can actually cancel r. In this case, we can actually cancel r, right? Because in both sides, we can divide both sides by r. Thus, 3 times the mass times the gravitational acceleration should equal the tension. Now we have an equation which requires the tension, which we have, remember, we calculated to be 5,197.25 newtons, and the gravitational acceleration we have. Therefore, if we rearrange that equation, if we take this equation and we rearrange it, we get that the mass m is equal to tension divided by 3 times g. So the tension divided by 3 times g, so mass is equal to the tension, which we calculated it earlier on to be 5,197.25 divided by, that's newtons, the tension divided by 3 times the gravitational acceleration of 9,8, and that is in meters per second squared. Your answer will have a mass of, that's in kilograms, the answer will have kilograms. And if you work it out, you should get around approximately 177 kilograms will balance that bucky. So 177 kilogram. Accurately, it's 176, but it's around 177 if you want to just round it off the nearest whole number. So that is how we do that question. It's around 177 there. Should be around 177. Let's click it and check if it's correct. Now, let's go to the next question. If you have any questions, like earlier, I'm going to give you like 20 seconds. If you have any questions, just switch on your mic, start speaking. If you want me to repeat certain stuff, just tell me. And the next question This is a very interesting one, but now I've written on the thing, so I might have to redraw it. Let me just, while you guys think of maybe if you have a question, I'm going to redraw the whole situation here, if I can. So, question 3, let me highlight it. A hungry bear weighing 700 newtons. Okay, so this is the situation. Okay, so this is a wall. We have a pivot there. On there is a basket. And in that basket is some bread, a baguette. There is, I don't know, a lollipop. That looks like a rose. Whatever, there is some goodies in this basket hanging on this pole. Okay? And on this pole is the bear. There is a bear. This is not a human being. I'm going to draw its nails. This is a bear. It's a terrible bear, but pretend it's a bear. So they say a hungry bear weighing 700 Newton walks out on a beam. Okay, and this bear is attempting to retrieve this basket here. This bear is attempting to retrieve this basket. Let me redraw the bear. There we have a beam. And at the end of this beam, they tell us there's hanging a basket of goodies. There is a basket of goodies hanging the end of this, and there are some goods for the bear in there. There is some fruits, whatever. There's a bottle of water, whatever. There are some things in that little basket there, the bear, and they tell us that this bear walks out on a beam. It is walking. This is the bear. It is a bear snout, small bear ears, a bear head, and it has a stick. This is the bear. It's a terrible bear, but let's just pretend that it's a bear. So there is the bear. It is walking out on that beam. It has a weight of 700 newtons. So this bear has a weight of 700 newtons. So this is a bear with a weight of 700 newtons trying to get to that basket of goodies hanging there. Now they tell us that the beam is uniform. This beam weighs 200 newtons. It is 6 meters long. This beam is 6 meters long and is supported by a wire at an angle of 60 degrees. And it is supported by a wire at an angle of 60 degrees. So it is supported by a wire at an angle theta, 60 degrees. The beam itself weighs 200 Newton. It is 6 meters long. And what information did they give us? The basket weighs 80 newtons. So the basket has a weight of 80 newtons. 80 newtons. So that is roughly what is happening. Now they're telling us to draw a force diagram for the beam. A force diagram for the beam. So this is basically what's happening. Now let's draw question A. Draw a force diagram for this beam. Now there are a lot of forces. I need a new page. Now there are a lot of forces acting on this beam. Quite a lot, mind you. You need to, that's why they ask you to draw a force diagram first, so you can actually. So question number 1, they ask you to draw a force diagram of this whole situation for the beam. Okay, now this is the beam. This is the beam. Now on this beam, a certain distance x, a certain distance x away. We don't know where, but this bear is walking on the beam somewhere. So a certain distance x away is the bear. Okay? This bear is a certain distance x away, and this bear, let's say this right there, that bear is a distance x away from the tip of the beam, and this bear has a weight of 700 newtons. And let's say this is the midpoint of the beam. Okay, so this would be, the beam is in total 6 meters, this would be 3 meters. Well, this would be 3 meters. Now this is not to scale, of course. Just try to picture it. So the bear is here, some distance, with a weight of 700 newtons. It is a distance of x away. Then, of course, the rope pulls on the beam with a tension T. And let's call this point A and this point B. And of course, here we have the basket at the end at point B weighing 80 newtons. We have the basket weighing 80 newtons there. And we can, of course, break this force of tension into its components. T cos of 60 and then T sine of 60. The force going upwards would be T sine of 60. And this, of course, going that way, this would be T cos of 60. Going that way, T cos of 60. If you just were to break it up into components, that would be T cos 60. And of course, there are two forces here at this end at point A as well. There is a force Ra, Ry, and there is an Rx. There we have it. And then right in the midpoint, 200 newtons, that is the weight of the beam. because we assume that all its weight is acting on its midpoint. That is the force diagram. It looks a little bit cluttered, but as long as you know what everything means and where everything is, it is fine. Should be fine. Okay, now we have drawn the force diagram. They ask us when the bear is at x equal to 1 meter. Okay, so when x is equal to 1 meter, find the tension in the wire supporting the beam and the components of the force exerted by the wall on the left end of the beam. So these two forces, Ry and Rx, are the components of the forces on the beam by the wall. Okay, so this is the forces that the wall exerts on the beam, Ry and Rx. Now they're asking us when the base at x equal to 1, find the tension in the wire. Okay, so when x is equal to 1, find the tension in the wire. So find T. So find T. So when x is equal to 1, we need to find T. How do we go about finding T? We know that this thing, this beam, is supporting the system and is not the beam is uniform, weighs 200 newton and is 6 meters long and is supported by a wire at an angle of 60 degrees. The basket weighs 8 newtons and there's a hungry bear on it. And we assume that this beam is not moving. Okay, the beam is still. That means the sum of the momentum around sum of the momentum, the moment, okay, the moment, not momentum, sorry, which is equal to 0. Sum of the moments around point A is equal to 0. Now we've done moments, it is just force multiplied by distance. Okay? Force, so it's perpendicular force multiplied by distance. That is moment. Now, the moments about A is equal to 0. About that point A, this is the point A. So this is the point A here. Okay? Now we calculate all the moments around that point, okay? Meaning all the forces along this beam. Okay? Let's say the first force acts at a distance of 1 meter. The moments around this point, all the moments around this point should be equal to 0. Okay. Now, so the first force acting on this beam perpendicular is the force of the weight of the bear, and it's going downwards, so it's negative 700 multiplied by it acts at the distance of 1 plus or minus, choose, depends on which you choose. Okay, so negative. Then the next force is the weight of the beam itself. It's 200 and it acts at a distance of 3. Let me keep it like that. Okay, so let me try to do this. I almost bended it. This, so I can that. Take this one out. So the sum of the moments about point A should equal to 0. Now moment, we know, is equal to just the perpendicular force, the force acting perpendicular on the beam, multiplied by the distance from point A. The distance from point A at which it acts, Ra. So the distance from point A is a moment. So the sum of all those moments should be equal to 0. Now let's calculate all those moments. Okay. So the first moment is this one, due to the bear. The first force, it is going clockwise. So we say negative the force is 700 x at a distance of 1. And then the next one, the force is 200 it x halfway. It's the weight of the beam itself. So 200, and it's at 3, acting at 3. It's halfway across the beam. Then the next one, negative, is the basket. It acts at 6, so the basket is 80, and it acts at a distance of 6 meters. So there we have all the moments going clockwise. Okay, so all the clockwise moments. And then there is one plus, there is one moment going in the opposite direction. It is this moment here, going straight up with t sine 60. That is t, the tension, sine of 60. And this all should be equal to 0. Okay, so now we can actually just work all of this out to get the answer. Oh, that force acts at a distance of 6. It's going upwards. So at the end, so it acts at a distance of 6. So what we're left with is all of that. If you account for all of that, multiply 700 times 1, 200 times 3, 80 times 6. Let's check what is 80 times 6. So it will be negative 700, negative 600 Newton meters. Of course, I'm not putting the units. 80 times 6, my calculator. 480, negative 480 plus t sine 60 times 6. That all is equal to 0. If we take it over, that is 700 minus 600. 700 plus 600 plus 480. That is t sine 60, t sine 60 multiplied by 6. If we take all of them over, we get 1780 Newton meters. We divide it by, to get tension, therefore if we divide by sin 60 times 6, the sine of 60 times 6, we get an answer of 342. The sine of 60, if I remember correctly, is square root of 3 over 2. 342.6. So that is the tension, newtons. In newtons, of course. So we found the tension. We worked out the tension, 342.6 newtons. So now we know what the tension is. We've worked out the tension T. Now they're asking us, also in that same question number 2, they're also asking us the tension in the wire supporting the beam and the component of the force exerted by the wall on the left end of the beam. So at point A, so 1 Ry and Rx. Now the sum of the forces in the x direction is equal to 0, and the sum of the forces in the y direction is also equal to 0 because the beam is perfectly balanced. Okay? So the sum of the forces in the x direction. Let's start with that. Sum of the forces in the x direction. There is only two forces in the x direction. There's two forces in the x direction. There's Rx and T cos theta. They are both in the x direction. So, therefore, if this is equal to 0, then Rx should be equal to T cos 60. That is why we first had to calculate the tension. Okay, and that is equal to, if you multiply the value that we just got for the tension by the cos of theta, you will get 171,28 newtons. Okay? So if you multiply the tension that we just worked out, tension that you just calculated, this tension here, 342.69 times the cos of 60, you will get that particular tension. Okay, now the sum of the forces in the y direction is a bit more. Sum of the forces in the y direction is a bit more. So Ry is then equal to all the forces going down. There is, we add up all the forces going down and we subtract the forces going up. So all the forces going down is the 700 Newton of the bear plus the 200 Newton of the beam plus the 80 Newtons of the basket. That is all the forces going down. That's all the forces going down. That's all the forces going down, and then there is two forces going up, or we subtract the force going up. In this case, the force going up is equal to the T sine theta. So it's T sine 60. That's the force going upwards, this force. Okay, all of these forces. This force is the only force going up, and then this is the weight of the bear, this is the weight of the beam, this is the weight of the basket, and then one force going up. So all of these going down minus the force going up will give you the force Ry. Okay, so that will give you the force Ry. Now sine 60, we work it out. You just plug in the tension that you calculated and the sine of 60. If you work this thing out, Ry is equal to 683.34 newtons. We can let's just go check before we continue any further. Let's check if we have done this correctly. So we have done the force diagram. We first worked out that the first force, we worked out that the tension, remember we worked out the tension and it was equal to 342.6, and then they tell us here that the answer for tension should be 343. Okay, so if we round this off, it's 343. Now the next thing we had to work out was Rx, the force in the horizontal direction. It was 171, and that is exactly what they got well. And then we worked out the force in the horizontal, the vertical component, the vertical direction. We worked out that force. Although they say we didn't actually have to work that one out, but we did. Now number three, they're asking us the third part of this problem, part number 3. They ask if the wire can withstand a maximum tension of 900 newtons, what is the maximum distance the bear can walk before the wire breaks? Now, the wire, okay, that is not the correct, that thing looks weird. I didn't make a mistake. I just drew the symbol weird there. You go. Sum of the torques be equal to 0 for this beam. Okay. Now the sum of torque should be equal to 0. Now let's say this bear weighs its torque is going clockwise, so we put a negative there. The distance it travels is some distance x, and then beam is 200 newtons, and it is 3 meters. The basket 18 newtons and is at some distance 6. Then the vertical component of the tension is positive, it's going upwards, it's counterclockwise. So the vertical component of the tension is equal to okay, it's just the tension and the sine of 60 going upwards. So those are all the forces acting on this beam. Okay. Now we just need, and they should all be equal to 0. Okay. Now, in order for us to work, now we just work out the value of x. Okay. It's just a simple math. If you work out the algebra, you found that x is equal to 5.14 meters. Okay. Now that is the distance that this bear can walk before he breaks this beam, before he goes and breaks the beam or snaps the cord. This is the maximum distance that this bear can walk before the beam snaps. Because at this exact distance, it is perfectly balanced. But if this bear goes over 5.14 meters, the beam will snap because the clockwise torque will be more than the counterclockwise torque. Meaning the upward force on the beam at the end, the T sine 60, will not be enough to hold the weight of that bear. Now, if you have ever walked on a diving board at a swimming pool, you know that the board bends at its most when you are near the end of the board. Okay, so when you are not near the wall or the ladder where you get up, but when you are near the end, it bends at its most. That's because at that point, the torque, the torque caused by your weight is at its highest. Okay, now this bear can only walk a certain distance before its weight breaks the beam. Now, if you have any questions regarding that problem, by the way, that is a problem that was taken out. That was in an exam paper once. There we have it, 5.14 meters. Now, this particular problem has to do with harmonic oscillation or simple harmonic motion. And it is quite a nice problem. Let's look at it for a moment. Okay. Problem number 4. Let's look at it. Now, harmonic oscillation, simple harmonic motion, SHM, simple harmonic motion. It says here, in an engine, a piston oscillates with simple harmonic motion, so its position varies according to the expression. Now, they don't give us the expression, but I will give you the expression. This expression that they should be there is equal to 5, which is the amplitude, cos, the reason why it's simple, and 2t and plus pi over 6. This is simple harmonic motion. This is the formula. Okay, this is position, and this is the formula that gives you position. Okay, this angular frequency, that is the phase angle. Now, if you have not done this and you are checking it at a later stage, please make sure you know what each one of those means. This is the amplitude A. This is the amplitude A. This 2 is equal to the angular frequency. This is time. And this is the phase angle. This is the generalized formula. X equal to this generalized formula. Okay, so this is the expression. Let me rewrite it on the clean page because that now looks messy. So we have an expression. X is equal to 5 cosine 2 times the time plus pi over 6, I said. Pi over 6. Now remember, when it comes to simple harmonic motion, we usually work only exclusively in radians. Okay, now at t equals to 0, what they're asking us, at time 0, find the position of the particle. So all you have to do is, for number 1, you plug in when time is 0. So x of 0 is equal to 5 cosine 2 times 0. So when time is 0, plus pi over 6. Now if you work that out, it comes to the cosine of pi over 6, because 2 times 0 is 0. So the cosine of pi over 6 is 4.33. And they told us there that x is in centimeters. So this is in centimeters and time is in seconds. So we've worked out what position this is, what position the piston is at time 0. Question number 2. Second question asks, the acceleration. Now, what is acceleration? We know that velocity is just the derivative with respect to time of the position, and we know that acceleration is the second derivative of position with respect to time. Acceleration and velocity. So we need to find the second derivative of this expression. Okay, so let's work it out. The second derivative, acceleration, that is velocity, and this is the acceleration. It is the second derivative of the position formula. Okay, so it's going to be, now first we need to find the velocity first. Sorry, this is the acceleration and that's the velocity. We're not at acceleration. We only have to do this acceleration first. So d dt, so the derivative of the position, which is 5 cosine 2t plus pi over 6. We need to find the derivative of that. Now the derivative, of course, is 5. The derivative of 5 is 5. It's a constant. It sticks outside. The derivative of cos is sine, negative sine. Derivative of cos is negative sine. It's 2t plus pi over 6. We're using the chain rule, and then multiplying by the derivative inside this is a constant. So 2t plus pi 6, that is one's derivative is just 2. So that derivative is just 2. So the answer will be equal to 2 times that is negative 10 sine 2t. If you need to, go brush up on your calculus because you're going to need it. Those of you will be taking, who's doing FVV, you'll be doing this a lot with me later in your course in 2 weeks time. Now, the part 3 of this question say it's acceleration. Now we know acceleration is nothing but the derivative of velocity with respect to time. And we already know, so that's basically just d dt, the time derivative of the velocity. We've already found a formula for the velocity, and it is equal to negative 10 sine 2t plus pi over 6. Pi over 6. That is the derivative of, there's two brackets there. That is the velocity. So the derivative of the velocity is equal to the acceleration. If we find the derivative of this, it'll give us negative 10, still stays outside. Derivative of sin is cos. That's 2t plus pi over 6. I'm going through this, and then the derivative of this is just another 2, meaning the answer is negative 20 cosine 2t plus pi over 6. We are finding the derivative with respect to t. You should have done enough derivative calculus for now to be able to do this using the chain rule. Okay. Now they're asking us to find the velocity and the acceleration at time 0. You just plug in time 0 there. You should have both of those answers. I'm just doing the big picture. You plug them in yourself. Then for number 4, find the period. Now period t is equal to 2 pi over the angular frequency. I know this is angular. So 2 pi over the angular frequency. 2 pi, and the angular frequency in this case of this expression is 2. The angular frequency is 2. Here, remember the expression was, this was the original expression. This was the original expression, 5 cosine x is equal to 5 cosine 2t plus pi over 6. So this here is the angular frequency, 2. So this is 2. So the answer is pi. So 3.14 seconds. Okay. The answer is pi 3.14 seconds. And you can check there, it's 0.14 seconds. Now, V, the amplitude of this is just 5. You can read it off. 5 is the amplitude. It's just 5 centimeters. It's the number in front of the cosine of the original expression. Now we've got all of that correct. If you have any questions regarding this, I'm happy to go over it again. Please ask. And now our last equation, our last problem. Now I know this takes time, and some of you complain that it takes about 2 hours to do these problems. That is because we do them thoroughly, so you know what to expect. Okay, so problem number 5. A particle exudes simple harmonic motion with an amplitude of 3 centimeters. At what position does its speed equal half its maximum speed? So at what position? Okay. Now, I don't know how much you have done of oscillations, but if you haven't done oscillations yet, this will come in later on. So the problem says a particle exudes simple harmonic motion. Now, from energy considerations, from energy considerations, if you are not at this stage yet, Don't panic. You can watch this at a later stage. You know that the velocity squared plus w squared, well, the angular acceleration plus x squared is equal to w squared times the energy squared. Okay, just follow the math. Now we know that Vmax, we know that maximum velocity, we know that the maximum velocity Vmax is equal to the angular frequency times A. And that V is equal to the angular frequency times A over 2. Thus, if we rewrite this thing here, if we rewrite that in terms of V, we have that V is equal to WA, just normal simple algebra at this stage. Simple algebra. If you're not at this stage yet, I know one group of you guys is not here yet, but it's okay. Just try to follow as far as you can. W squared x squared equals to W squared A squared. Well, this is not W, is the Greek letter. Angular frequency, fine. Therefore, this and this is just half of that one. So if you divide throughout by W squared and then you subtract, this is A squared over 2, you just get this is A squared over 4, so you get 3 over 4 A squared, and this side you're left X squared. This is just normal, this is just a simple algebra. A squared, this is A over 4 eventually, this is A squared, this is A squared over 4, so if you subtract it, you have 3 over 4, 3 quarters of A squared left. And what you're left with this side is X squared. Now since they tell us that A is equal to 3 centimeters, we have that X in this case is equal to plus minus the square root of 3 over 4 A. And if you work it out, A is equal to 3 centimeters, so therefore X is equal to plus or minus 2.60 centimeters. That, ladies and gentlemen, is the answer to our last and final problem. And I know some of you may not understand that last part on harmonic motion, but you will when you actually do it in class and then you just come and review these problems. Thank you for listening, and I will see you next week. Well, actually, I'm doing Arnold. I'm covering for Arnold on Thursday. All the best and enjoy the rest of your day.